Okay, so our next section is notes. This is actually the last thing we're going to learn before the test, but it's a pretty meaty thing. It's a pretty big thing. So you should be on section 3.4. Your notes say 3.4a and b. Okay, so we're going to learn how to graph a quadratic function in vertex form. Okay, graphing in vertex form. Now, what we did last time, we did 3.3a. Okay, and we learned to graph when it's kind of in this form, ax squared plus bx plus c. All right, so we learned to like identify a, b, and c, find the vertex using negative b over 2a, find the axis of symmetry. Okay, so we're skipping forward now, so you have some sections in your notes that you're going to skip. We're not going to do 3.3b or 3.3c. We're going to skip to 3.4a and b. Okay, so we're going to learn how to graph. We're going to keep graphing quadratics, but basically we're going to learn how to graph when it's written in a different form. So I'm going to go over to Desmos and pull this up. Okay, so far we've graphed a bunch of quadratics. So here was our parent function, remember? Y equals x squared. So let's kind of a little bit summarize some of the things that we did at the beginning of this unit. So we learned that if I put a number in front of this x squared, like let's say I put a 3, that makes it more narrow, right? It stretches it. Let's say I put a 6. Again, that stretches it, makes it more narrow. What if I put a negative 2? Okay, the 2 makes it more narrow, but the negative takes it and reflects it down, right? Anytime I have a negative in front, it reflects it down. Okay, what if I have like a 1/3? Okay, that made it wider. Okay, if the number in front of the x squared is less than 1, that makes it wider. Okay, so we did those, kind of stretch and shrink. We also did this. If I like add 4 to the end, it's going to shift it up. So we did vertical shift up and down. So if I add 4, it'll shift it up. If I add 9, it'll shift it up 9. If I subtract 5, it'll move it down 5. Okay, so we've kind of learned about vertical shift, moving it up and down. What we haven't talked about yet is moving it left and right. So that's a little bit of what we're going to do today, or the main new thing we're going to introduce today is moving it left and right. Okay, so what I'm going to do to move this left and right, I'm going to add, so look in the top left corner where my function is. I'm going to add some parentheses around this x right here. Okay, all right. Now, so that's the same thing, right? Parent function x squared, I just put parentheses. Now, if I add a number to the very end, it's going to move my graph up, right? What if I add a number that's inside attached to the x? So what if I had like x plus 2 squared, okay? So take a look at my function. It's x plus 2 squared. So see where the plus 2 is? The plus 2 is like inside the parentheses with the x, okay? It's not on the outside. That whole thing is being squared. It's inside the parentheses next to the x, okay? Now notice how I did plus 2, and look at my function. It moved left 2, right? It's just like I took the parent function, so this is the parent function, and plus 2 made it move left 2. Okay, what if I do plus 4? Left 4. What if I do plus 1? Left 1, right, from the origin. So what if I do plus 8? It moved left 8 from the origin. Okay, what if I do minus 7? Okay, so that moved right 7. What if I do minus 3? It moved right 3. Minus 1, it moved right 1. Okay, so something interesting about left and right is, to me, it actually is moving the opposite direction of what I would think. I would think that if I put a minus, like minus 4, I would think it would move left, but it actually moves right. Okay, and if I put a plus 4, that's how it's going to move left. Okay, so it's if I add or subtract a number on the inside of those parentheses attached to the x, it's going to move it left and right. So if I'd put a plus 4, it moved it left 4. Okay, so I can do other things to it. If I add a number to the end, see if I do like a plus 2 on the end, that still moved it up 2 because numbers at the end move our function up and down. Okay, so the plus 2 shouldn't be anything different. Moving up and down we've already done. What's different is now we also moved left 4. Okay, I can also put a number in front, just like before. Look, if I put a 3, makes it skinnier. If I put a negative, reflects it down. Okay, so that number out front, again, no surprise. If we put a number bigger than 1, let's try 5. It's going to make it skinnier. If I put a number smaller than 1, it's going to make it wider. Okay, so it's basically like the same thing I've done before where the number out front stretches or shrinks it. The number at the end moves it up and down. Now the only difference is now I'm adding this number that I'm adding or subtracting from x on the inside of the square. And that's going to move it left and right. And it's kind of the opposite direction of what you would think. Plus moves it left, minus moves it right. Okay, all right, now let's go to the notes. Let's solidify this. I just wanted to show you on the graph. Okay, so in our notes, we have our parent function right here that we can look at. And then we have vertex form of a quadratic. Vertex form of a quadratic. Now, the reason that this form is called this is because it's really easy to see the vertex. Let's switch back to my graph. What's the vertex here? -4, 2. Okay, look at my function in the corner. Okay, my +4 on the inside, that means I moved it left 4. So I have a -4 in my vertex. The +2 means I moved it up 2. So my vertex is -4, 2. So to create my vertex, I just have to take the number that's being added or subtracted from the x, I have to take the opposite of it, right? Because the +4 means I actually moved left 4, so I get a -4, and then I have to take that number at the end, that 2 becomes my y value. Okay, that's why it's called vertex form. It's really easy to get the vertex from it. Okay, so if I'm looking at, now this has been generalized, so look at this right here. Okay, so let's look at what each of these do. Now A is my number out front, right? So A is my stretch and my shrink. Okay, so we've had lots of practice with that, right? If A is bigger than 1, it's a stretch. If it's smaller than 1, it's a shrink. Okay, also remember, if there's a negative out front, if negative in front, that means we reflected the graph. Okay, so watch for that in front. Okay, all right, let's do K next. What's my K right here? Okay, my K is my vertical shift. Okay, vertical means up and down. Okay, again, we've done this before. Okay, if you have like a +4 at the end, it'll shift up 4. A -4, it'll shift down 4. Okay, now the new thing is my H right here. Okay, whatever I attach to the X on the inside of those parentheses, that's going to be my horizontal shift. Horizontal shift. Okay, so that's left and right shift. Okay, all right, so you need to think about how H, the amount that we're actually shifting left or right, it's the opposite of what we see here in the parentheses. So if I have x minus 2 squared, that means we're going to the right 2. Okay, so that means my vertex is going to have a positive 2 right there because I moved right 2. Okay, now if I have something like x plus 4 squared, that means I went left 4. So that means in my vertex, I'm going to have a -4 right here. Okay, all right, so and if you're having a hard time, if this isn't really making sense, hang in there, we'll do some graphs and you'll be able to see it a little better, okay? All right, so let's go down, let's solidify this a little bit more. So if we have a graph in vertex form, if it looks like this, our vertex is going to be HK, okay? We get H from right here inside the parentheses, and we get K from the end. However, don't forget that H is like opposite sign as the number in parentheses. Okay? And then because H is the x value of our vertex, that means that the axis of symmetry is going to be x equals H. So you can write that down. Okay? So I know some of this seems a little abstract with the H's and K's and stuff. So let's actually pause on anchor points and max and min and stuff. Let's go down and let's actually just graph one and let's see if we can understand this better. Okay, so let's look at our function right here. Now, I know that this is in vertex form because I see kind of this number being added or subtracted to the x inside the parentheses. Okay, so I'm going to graph it. So let's find the vertex. Okay, now what this means is right here, we have a graph. Remember, our parent function starts right here at the origin and goes like this, right? I mean, more or less, okay? Our function starts at the origin, but what's happened here is, look, we've moved left 4 and down 1, okay? So the -1 gives me a down 1, and the +4, remember, if it's +4, I'm actually moving left. Okay, so that thing in the parentheses, we're going to kind of move the opposite of what you would think. So let's plot the vertex. We move, remember, at the parent function, we start here at 0, 0. But instead, we're going to move left 4, and down 1. Okay, that's going to be our vertex. So instead of having our vertex at 0, 0, we moved left 4, down 1. Okay, so that means our vertex is -4, -1. Okay, so we can actually just look at this equation and we can know what it's going to be. Okay, our vertex is going to be the opposite, our x value is the opposite of whatever this number is, and then we take this number. Okay, so there's our x, -4, because we moved left 4, and here's our y, -1, because we moved down 1. Okay, so the up and down, plus is up, minus is down, but the left and right, plus is left, minus is right. By the way, the reason for that, if you want to know, I can explain more to you on Monday. Basically, the most simple way to explain it is that you're moving, instead of moving the function, when it says +4, instead of moving the function right, you're kind of moving the x-axis right, which ends up moving the function left. So anyways, if that doesn't make sense, and it probably doesn't, don't worry about it for right now, okay? All right, so our vertex we can get just from looking at this equation. We just need to take the opposite sign of this and keep the same sign of this. Okay, all right, our axis of symmetry. Well, if this is our vertex, remember our axis of symmetry, let's do it thick so you can see it. Our axis of symmetry always goes through the vertex. Okay, it's this vertical line right here where our graph is a mirror image. Okay, so that the equation for that line, we're at -4 right there. So the equation for that line is x equals -4. Okay, so that's why up here I said, okay, if the vertex is hk from this equation, the axis of symmetry is x equals h. Okay, so in this case, h was -4. So it was x equals -4. Okay, so far I have the vertex and I have my axis of symmetry. Okay, now let's do the anchor points. Okay, so we kind of skipped this right here. So we're going to come back to it right now. So also, I'm actually going to stop this video and start a part 2 just so the files aren't too long. So